Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. In this video, we'll explore how a simple chemistry concept, which is metallic bonding, connects to one of the world's biggest environmental issues currently, which is e-waste. So this is some of the learning goals that are very simple if you see the infographic, which is to understand how metallic bonding gives metals their useful properties, recognize the global impact of metal overuse and also e-waste, and explore sustainable solutions and reflect on our ethical responsibility as tech users in today's modern era.
Next, we will look into the metallic points. The first point, the sea of electrons. What makes metals special? Metals are made of atoms packed closely together. These atoms release their outer electron, creating a sea of delocalized electrons that move freely throughout the structure. The sea of electrons act as a strong metallic bond, holding the atoms together, making it strong, flexible, and excellent conductors. Due to that, metals are essential in electronics for wires and circuits. However, their widespread use contributes to a massive e-waste problem when devices are discarded, posing a major recycling challenge. The second point, metallic properties, strong, conductive, and malleable. Metals are strong and solid due to the powerful bond. They conduct electricity and heat very well through the sea of electrons. Metals can also be bent into shapes and wires without breaking. These properties make metals vital for all electronics. But when gadgets are thrown as e-waste, we lose these valuable materials. Recycling these metals is hard because they are mixed in complex devices, so they would end up in landfills instead of being reused.
Now, let's take a look at the significance of metal to the United Nations Sustainable Development Goal, UN SDG. One of the most relevant goals to metallic bonding is SDG 9, Industry, Innovation, and Infrastructure. Metallic bonding is what gives metal their key properties like strength, flexibility, and electrical conductivity. These properties are essential in industries around the world. For example, thanks to metallic bonding, metals like steel and aluminum are used to build strong bridges, durable buildings, and reliable transport systems. This helps create resilient infrastructure that lasts longer and uses fewer resources over time. Also, metals like copper and silver, which have freely moving electrons due to metallic bonding, are excellent conductors of electricity. This makes them incredible and valuable in green technology like solar panels, electric vehicles, and wind turbines. Technologies that are actually crucial for a sustainable future. Even better, metallic bondings allow metals to be melted and reshaped without losing their properties. This means metal can be recycled again and again, reducing the need for constant mining and helping us move towards a circular economy. So when we study metallic bonding, we're not just learning chemistry, we are learning the science between the innovation, sustainability, and the global progress.
Metallic bonding is what makes metals like copper, aluminium, and gold conduct electricity, stay strong and bend without breaking. These properties make them perfect for phones, laptops, and almost every gadget we own. But here's the problem. In 2022 alone, the world generated around 62 million tons of e-waste. That's about 1.5 million garbage trucks filled with discarded electronics, and only 22% of that was properly recycled. The rest? It ends up in landfills or in toxic informal recycling sites, especially in poorer countries. Here's a wild fun fact. E-waste contains $91 billion worth of recoverable metals like gold, silver, and copper, thanks to metallic bonding. But we're only recovering a fraction of that. Asia generates the most e-waste, about 25 million tons, but recycle just about 11 to 12% per year. Based on the graph, this is by capita, but in total, Asia still dominates in this situation. Europe's recycle the most, about 43%. And get this, one smartphone contains only 0.034 grams of gold. That might sound small, but if you collected all the gold from the world's phone, you could build around 30 Eiffel Towers made of pure gold.
Today I'll be explaining about e-waste and recycling and also some analysis of the data. And next, I'll also be explaining about real-world issues related to this topic. Okay, so as you all can see here, the graph here, amount of e-waste generated and collected. So the dark gray one is the total e-waste generated, and light blue green is amount recycled, and the pink tax recycling rate in percentage. So the key trends and concerns here is Europe and Oceania are doing relatively well in managing e-waste with over 40% recycled. However, for Africa and Asia have very low recycling rates, showing limited access to proper e-waste management systems. So this imbalance highlights a global issues. Countries generating e-waste are not always equipped to handle or recycle it responsibly. And for the real world issues, so next I'll be explaining about the real world issues related to these e-waste issues. So first one, mining activities involve removing large amounts of soil, which destroys the natural landscape, and this leads to soil erosion, making the land unfit for plants and animals. So and chemicals used in mining can pollute rivers and groundwater, affecting wildlife and human health. So that's why it can cause water pollution and deforestation. Then the second one is when electronics like phones or computers are burned to extract valuable metals, it releases toxic gases and particles into the air that include dioxins and heavy metals like lead and mercury, and this can cause very serious health problems such as cancer, breathing issues, and brain damage. And the last one, about the child labor. Okay, so basically cobalt is a key metal used in batteries. So in some regions, in some countries, children are often forced to work in dangerous conditions with no protective gear and earn very low wages, even though cobalt is sold at high prices. So this can raise very serious ethical and human rights concerns about how the materials in our electronics are sourced. So that's all for